Good morning, students. The last class we discussed about how to find the period and block and group if they given the uh, electronic configurations like one value like 3s. How can you find the period and block and groups? So we have discussed in previous video, and periodical properties, that is atomic radius and effect of atomic radius and variations of atomic radius in groups and also a period. And we discussed about covalent bond and van der Waals radius and ionic radius and metallic radius, and also we discussed just isoelectronic ions and variations in groups. Isoelectronic ions are variations, how the variations appeared in groups we discussed in the last video. In now video we are going to discuss that the last video of classification of periodical table, that is ionization energy. We are going to discuss ionization energy and variations of ionization energy in groups and also periods. We are going to discuss in this video on the factors, which factors will affect the ionization energy, and we are going to discuss that atomic size and electronic configuration, how to write the electronic configurations, and shielding effect and screening effect. We already discussed in offline only what is this shielding and screening effect. Once again we are going to discuss with the definition, that is shielding and screening effect. Okay, and electronic affinity means, see, electronic affinity we call it EA, and we discussed that variation of electronic affinity, that is in groups and also periods. I am showing in arrow marks. Okay, and factors, which factors will affect the electronic affinities, we are going to discuss in this video. And also the last the electronic negativity, in the what is definition of electronegativity, definition and also variation and factors affecting the electronegativity in both variations means in groups and also periods, and which factors will affect this electronegativity, we are going to discuss in this video. And last of this chapter, that is we are going to discuss that definition of valency and also oxidation. What is the difference between valency and oxidation? So very important for your exam purpose. And also variations of valency in groups and also periods. Similarly oxidation also we have already seen while discussing the S and P block elements in your offline class. I have told that valency will be changes, oxidation numbers also will changes while discussing that group 13 and group 14 and also group 1 and 2 elements. While discussing these groups, I already told that valency and oxidation numbers, how the variations are appeared. Correct? Now we are going to discuss briefly about these topics in this session. Okay? Ionization energy. You see, ionization energy, or it may be also called as ionization enthalpy, ionization enthalpy and also ionization potential, ionization potential. You see, the ionization, before talking ionization, the ionization is nothing but the energy, the energy required to remove the electrons from isolated gaseous, okay, from outermost shell. You see, to remove, you see, this is a nucleus, this is the shells. To remove the outermost electrons we need some energy, okay, that is nothing but ionization energy. Okay, first we define it, or definition the amount of amount of energy required to remove required to remove outermost, see, the energy required to remove outermost electron from an isolated gaseous neutral atom. I said it is outermost electrons. Okay, outermost electrons. For example, you take an atom, must be in gaseous state. Ionization energy it used only in gaseous state atoms. Okay, the gaseous state atom, I taken that A is atom. I given to that ionization energy IE to the atom, it removes the outermost electron. If it removes, what happens? It become A plus, correct? No, it removes the electrons. Okay, that we call as delta H. Okay, delta H may be, you see, one is positive charge, one is negative charge. When will the positive charge energy absorbed? If energy is absorbed, okay, see, the energy is absorbed, that time it must be a positive charges, then it will be, or every time ionization energy delta H is positive charge only, positive charge. Okay, negative, if for some cases energy is released, okay, it is exothermic reactions. Only in exothermic reactions enthalpy is positive, ionization energy will be negative, ionization will be negative. If endothermic reactions, ionization energy will be positive. Well, ionization energy will be negative when the energy will be released. Okay, the units for ionization energy, kilojoules per mole, or another one is electron volt per atom. 1 electron volt per atom is equals to 96.42 joule per mole. Okay, see, consider if you take any metal, for example, I will take metal, that is M, metal in gaseous state. Okay, metal in gaseous state, we use ionization energy. Okay, ionization energy, that time metal became positive, it leaves electrons. Okay, for that it become positive, we call unique positive, it is unique positive ions, we call it is a unique positive ion. Well, come to this ionization, we called ionization E1 because it is first ionization energy, correct? No, first ionization energy. Again, if we remove another electron from the positive metal, that is M plus, if we again gaseous state, if we again give the ionization energy, it gives M2 plus it gives another electron, correct? No, this IE called ionization energy, second ionization energy. You see, the second ionization energy is greater than first ionization energy, because you see, in first ionization energy, electrons are removed from the neutral, because it is in neutral state. No, it is in neutral atom. We are removing electron from the neutral atom easily. But when come to second ionization energy, we are removing the electron from the positive ion. Positive ion. Okay. For electron be the less in the number of protons. Okay, I will tell that. Why ionization energy 2 is greater than ionization energy 1? Why? Because ionization energy in first, electrons removed from parent atom or neutral atom. When come to ionization energy 2, electrons are removed from the positive ion. Okay, do you understand this? Ionization energy. Okay, next, if you want to give another reason, this is a one reason. If you want to give the another reason, you see, the electrons will be less in number of protons when compared to more positive nucleus increases. Okay, we will talk another variation of ionization energy in periodical table. Variations in ionization periodical table. If we take a periodical table, this is period, this is group. Okay, first we are going to talk about groups. What happens in periodical table? You see, in groups, from top to bottom in periodical table, the ionization energy decreases. It will be decreases. Then come to here, it will be increases. Okay, groups, ionization energy decreases. Why decreases? Because we move top to bottom in the group, the atomic size it will be increases, correct? No, it will be increase. Atomic size will be increases. Then addition of electron shell, distance between the nucleus and valency of electrons increases. You see, in the atomic size, when to top to bottom, what happens? You see, this is a nucleus, atomic size increases, correct? No, atomic size increases. If increases, nucleus to valency shell, the electrons, the distance between the nucleus and valency electrons will be increases. If increases, then the nuclear force of attraction will be decreases. Nuclear charges are nuclear force of attraction. Force of attraction decreases. For example, you take lithium, sodium, potassium, rubidium, cesium. Okay, you take for lithium is 1s2 2s1, correct? No, it's having 1s 2s. When come to sodium, if we talk, sodium is 11, 1s2, 2s2, 2p, 6, 3s, 1. Correct? No? One orbital, second orbital, third orbital. You see, the atomic size is increases. This increases the inner electrons will produces. Okay. This increases inner electron will protect the valency electrons. See, increases the inner electrons. If it increases the inner electrons, it protects the valency electrons. Inner electrons means, for example, these electrons will protect the valence electrons. The valence electrons, which we call it as shielding effect, or also called protective effect. Why we call shielding effect? Because increasing inner electrons will protect the valency electrons. We call it as shielding effect. Okay, we talk on the groups. Now we are going to talk about periods. Already I told that ionization energy will be increases. Why it increases? We take a third period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen. Because from left to right side of the periodical table, atomic size decreases. You see what happens here? It is opposite. Atomic size decreases. Then nuclear force of attraction increases. Okay, the atomic number increases, the nuclear charges will be increases, atomic radius decreases, it is close to the nucleus. Now factors affecting ionization energy. First factor, atomic size or atomic radius. Okay. Second, nuclear charge. Third, shielding. I already told what is shielding. Effect. Fourth one, electronic configuration. Fifth, removal of electrons from the orbitals. Removal of electrons from orbitals, that is s, p, d, f orbitals. These are factors affecting the ionization energy. Okay, next we are going to talk that in the first atomic size based on the ionization energy. Okay, atomic size of the atom will be decayed the distance of the valence of electrons from the nucleus. We know that first of all the ionization energy is inversely proportional to atomic size. If ionization energy increases, then atomic size must be decreases, because the attraction between the nucleus and electrons decreases, okay, with increasing the atomic size. Attraction between the nucleus and electron, valency shell electron or electrons, decreases with increasing atomic size. Correct? No? If atomic size increasing, what will be the distance between the attraction between the nucleus and the electrons will be decreases. If atomic size is smaller, then the attraction will be more. Okay. Second, we talk on that atomic size. Next, we are going to talk about electronic configuration. See, electronic configuration, it based on two types, that is you see, off filled orbitals, completely filled orbitals. Off filled or completely filled, it shows extra stability. Sir, how can you tell that off field or complete field shows the extra stability? You see, for example, I am taking nitrogen is atomic number 7, its electronic configuration 1s2, 2s2, 2p3. If p orbitals, if you write px, py, pz, correct? No? See, in p orbitals, the 3 off filled, it's off filled, correct? No? When come to beryllium, if its electronic configuration is 2, then 1s2 is completely filled. For example, I am taking that, okay? Is completely filled. You see, sodium and beryllium is ionizations. Sorry, nitrogens, I am not a sodium. Nitrogens and beryllium is ionization energy in the periodical table because of filled and completely filled. Okay. Next point, what we told, that factors affecting atomic size and electronic configuration. Another one is removal of electrons from the orbitals. Correct? Now, removal of electrons from different orbitals like s, p, d, f. You see, the nuclear force of attraction is more in s. Why, sir, it is more in s? You will have no doubt, because for that it is nucleus, s orbital, p orbital, d orbital, f orbital. S, P, D, F. You see, when come to nucleus near, it is S, correct? No, then it has the nuclear force of attraction is more in S. I am taking here, it is a nucleus. S is more compared to P. P is more compared to D. D is more is compared to F. Means nuclear force of attraction is more in S compared to P and DF. When I'll write that nuclear force of attraction. Nuclear force of attraction is more in S compared to PDF. When you talk nuclear force of attraction is more compared to P and D. P is more. Okay, the nuclear force will be maximum and minimum. Okay. Next we are going to talk about shielding effect. Already I told what is shielding effect. Okay, now we are going to deep shielding effect. Shielding effect or protective effect or screening effect. Screening effect. See, I will write the atom. Okay. These are the electrons, outer shell electrons. Okay, this is a inner shell electrons. Quite common it is nucleus. The electrons present in the inner shell, these electrons will try to protect the outer shell of the electrons from the nuclear force of attraction. Means attracting, it will be protected. No, the inner will be protecting the outermost by the attraction forces between nucleus and outermost electrons. It called shielding effect. Inner electrons attracted by the nucleus, there is a repulsion between inner and outer. You see, here also electrons are there, here also electrons are there. Here the repulsions are occurring. If it attracts the electrons, what happen? These electrons will be repulsion will be started, because like charges will be repel, unlike charges will be attracts. Okay, the inner electrons large is no shielding effect. Okay, I will write it. What I told, the electrons present in the inner shell electrons, this inner electrons, it will try to protect the outer shell electrons from the nuclear force of attraction is called shielding effect or screening effect. The inner electrons attracted by the nucleus, inner electrons will be attracted. The inner electrons are attracted by the nucleus, by the nucleus. This is repulsion between inner, there is a, we'll write a, there is repulsion between inner electron and outer electrons, because both have charges, both have same charges, negative charges. Okay, if inner electron charges larger, is no shielding. If you see, if inner electrons larger, if inner electron charge is inner electron larger, then no, it shows the number of shielding, because the more electrons is there in the inner, it will be protects the outermost, then number of shielding effect increases. When will be the shielding effect is more? When will be the shielding effect is more? When the inner electrons are more or larger. Okay, this shows that shielding effect. Okay, electron affinity means electron affinity is nothing but gaining entropy. You see, this is quite commonly electrons, correct? No, electrons gaining enthalpy. You see, electron affinity, it every time it will be the negative charge only, negative charge. Okay, first we are going to talk about what is electron affinity. Definition. We are going to talk about definition. Definition is the amount of energy released when an electron is added to an isolated gaseous neutral atom. You see, electron affinity is nothing but the amount of energy released when an electron is added to an isolated gases. You see, the last class I told that if electrons, you see, the electrons if absorbs, see, this is the atoms, if we are passing the amount of energy to the orbital, if it have two, one is positive sign, one is negative sign. See, when will the positive, the enthalpy means energy is being absorbed. Negative will be released. Energy will be released. It is endothermic. It is exothermic. Okay, you see, for that only I told that electron affinity is negative charges, because it will be released. Okay, we take example, like we'll take example, you take any atom having a gaseous atom, if the electrons is added to the atom, correct? Now quite common, it shows negative charges, gaining of electrons. And you can given the electron, also atom, we take example like another example, that is chlorine. Chlorine, it is in neutral state having a gaseous form. If you add electron to that, it become chlorine in gaseous state. See, this is while chlorine neutral to chlorine anion, its energy enthalpy change is equals to minus 348 kilojoules per mole. We want to talk about the units to measure the electron affinity is electron volt per atom, or we can also call as kilojoules per mole. Okay, you see, ionization energy will be positive. Ionization energy will be positive charges when come to, because it will be absorb the energy. When come to electron affinity will be negative because it energy released. Okay, we take another simple example to explain you. Okay, you see, example, I am taking that oxygen in the gaseous state. If we add electrons, it become oxygen anion. Okay, its energy affinity is a negative sign, correct? No, because it is first electron affinity. For that we will write 1. Similarly, if you remove from anion gaseous state, if you remove the electrons, okay, it releases. See, if we added the electrons to the primary oxygen anion, in that we will add a 2 minus gaseous state. It will be electron affinity 2, correct? No, it will be positive. Why it will positive? See, negative will be positive, correct? No, negative will be positive. You see, I am telling that first neutral state, in neutral oxygen, if we add a electron, it become anion. Okay, it is first electron affinity, it must be a negative. When come to here in anion, first electron affinity anion oxygen, if we add electron to that, you see electron charges is negative will be positive. For that I am telling electron affinity will be positive in secondary electron affinity. Okay, you see electron affinity, it is a non-metal property. First of all, electron affinity it is non-metallic property because non-metals, they are tendency to gain the electrons. You see, non-metals, why they can ask you electron affinity is a non-metal property. Why? Because non-metal they have tendency to gain electron in a periodical table. Okay, you see, in periodical table, halogens are very important point. Halogens, they have high electron affinity. I electron affinity. They can ask why halogens in periodical table, halogens having the I electron affinity, because the halogens, you see halogens, if you write the halogens electronic configuration ns2 np5, it need only one electron. It ready to take the electron from the energy, then it becomes the completely ns2 np6, correct? Now for that it have the I electron affinity, means it ready to it have the tendency to gain the electron from the periodical table. Okay, for that halogens are highly electron affinity. Next we are when come to noble gases, you see after completing noble gases they have, you see, noble gas or inert gas, you can take anything. Noble gas have zero electron affinity. Noble gas have zero electron affinity. Why it has zero electron? Because it is completely filled orbitals. It does not want any electrons to completely filled. Okay, for that it does not show any electron affinity. You see in periodical table, if gaining of the electrons occur, then it is electron affinity. If losing of the electron it occurs, it is ionization energy. Okay, next we are going to talk about variation of electron affinity. Here what variations are occurred in periodical tables. Okay, you see the variations of electron affinity in periodical table. If you talk that periodical table in two simple way, that is groups and period. What happens in groups? First we are going to talk about groups, correct? No, groups, the electron affinity means top to bottom electron affinity will be decreases. You see, it will be decreases. If decreases, it quite commonly increases. I will just sign. Then what will I want to write? In electron affinity decreases when top to bottom. Why decreases? Because atomic size increases. Then nuclear charges will be decreases, correct? No, what is nuclear charges? The distance between the nucleus and the valency of electrons. Quite common, atomic size increases means then nuclear charges will be decreases. Nuclear charge decreases. The force means the force of attraction between the nucleus and the electrons, it will be decreases. See, if you write the atomic size increases, then the attraction between the valency electron loss, nucleus to valency electrons will be distance is more, then nuclear attraction between these two nucleus and electrons will be less. For that I told that nuclear charge will be decreases. In the case of halogens, belongs to the group 17. You see, in the case of halogens belongs to group 17. You see, if you write the groups like fluorine, chlorine, bromine, iodine. Okay, see, fluorine, well, what I talked, if atomic size top to bottom it goes, it will be size increases, electron affinity decreases. Well, come to in the case of chlorine and bromine, I am talking about in the case of chlorine and bromine. Chlorine in some in cases like chlorine is greater than F. electron affinity of chlorine is greater than F. Okay, chlorine greater than F. Why it has more? We talk that F is F in the second shell, no? Chlorine is third shell. Then the F atomic size, I will write atomic size small, then its electronic configuration 1s2, 2s2, 2p5, correct, no? 2p5. In the p orbital, electrons is added. See, already I told that if electrons is added to this group, F, what happens? Electron is added. That time the electron in the p orbital, electron, sp, okay, sp, electrons will be already in the p orbital. If the electrons is added to this, what happens? Electron repulsions are occurring. Electron repulsions are occurring. Why it occurs? Because negative charges, like charges will repel, unlike charges will be attract. Similarly, you will tell to chlorine. See, if you talk about chlorine, is quite commonly atomic size big, correct? No, because the third shell it comes, P only, it becomes third shell. We'll write 1s2, 2s2, 2p6, 3s2, 3p5. Here you see repulsion occurring. These repulsions we call in the F, the electron repulsions are occur. It is more repulsions are occurring in p orbital, and it we call as inter electron repulsions. We call what we call inter electron repulsions, or inter repulsions of electrons. You can write inter electron repulsions. When come to chlorine, here also you can ask, sir, here also repulsions are occurring, no? Because it in P it is only one electrons, in P it having the electrons repulsions are occurring. But the atomic size compared to F, it is big, correct? No, atomic size is bigger then what will shows? It shows less, it shows the repulsion, but it shows less inter electron repulsions. It shows electron repulsions quite commonly, but less inter electron repulsion. Okay, for that we will tell that in the case of halogens belongs to group 17, chlorine is greater than fluorine. Okay, for that only I told that in the periods, if atomic size increases, electron affinity will be decreases. Okay, next we are going to talk about period. If we talk about period, electron affinity will be increases quite commonly. Why it increases? Because atomic size will be less. Atomic size will be less, and nuclear charges will be more. Nuclear charge will be increases. Okay, this is about the variations of electron affinity in groups and periods. Next we are going to talk about factors affecting the electron affinity. Factors affecting electron affinity. First point, atomic size, quite commonly atomic size. Second, nuclear charges, nuclear charge. Third, electronic configuration. Electronic configuration. How can you tell that electronic configuration will affect the electron affinity? The atoms which has completely filled configurations and off filled configurations, they have electron affinity will be 0. Okay, off filled. For example, you take in p orbital, if it fills off, or noble gases, you take completely filled off, it is off filled, it is completely filled. Okay, the atoms which have the off filled and completely filled, they have electron affinity will be 0, okay. Why? Because it will be 0, because extra stability and they have less tendency to accept the additions, because extra stability and they have less tendency to accept or to gain, okay, you write anything, accept or to gain addition electrons. These three factors will affect the electron affinity. Next we are going to talk about electron negativity. Electron negativity. You see, the electron negativity in 1931, Louis Pauling, 1931, Linz Pauling. Electron negativity was introduced by the 1931, the Linz Pauling. He given the definition that the ability of an atom to to share pair of electrons towards itself. Okay, see, for example, we'll take that, I'll write the definition lastly. You see, if we take x and y, for example, x and y, we take an example, there are two persons, we are given the tug off between them, it is center. You see, the x is weaker compared to y, y is stronger. Then what happens, this tug off, what the tag was pulled towards the y side, You see, we can give the another example, like HCl. You see, if you're going to write the configuration, 1s1 chlorine, we'll write that chlorine 1s2, 2s2, 2p6, 3s2, 3p5. See, it ready to gain the electron from the H. It become negative. Correct? No. It ready to pull the electron from the H, it become negative. Then loss of electrons, it become positive. Did you understanding here? We have taken, it's ready to pull the one electron from the hydrogen. For that, it gaining of electrons, we put a negative sign. When come to H, it giving the electron. For that, it become plus. Okay. Now we write the definition. The ability of an atom to attract shared pair, it become pair, no, it became shared pair of electron towards itself. Okay, next we are going to write the difference between electron affinity and electron negativity. Electron affinity, electron negativity. Okay, while electron affinity, it accept the electrons, means the electron negativity is accepting, correct? No, electrons accept electrons, but it attracting attract electrons. Then it is isolated atoms, it is bonded between both, it will be bonded, no, it will be taken as bonded atom. It has electron affinity, already told that units, that is what I told, kilojoules per mole or electron volts per atom, correct? No, it's have measured quantity units. We'll take that measured quantity units, that is electron volts per atom or kilojoules per mole. Okay, when come to here electron negativity, there is no units. Now we're going to talk about variations of electron negativity. Variation of electronegativity. If we talk in periodical table variations, we will write that period and group. Electronegativity will be decreases. Group, it will be decreases. Here increases. Group electronegativity will be decreases because atomic size increases. Nuclear charge quite commonly will be decreases. When come to period electronegativity will be increases, atomic size decreases, nuclear charge will be increases. Okay, next we are going to talk about factors affecting the electronegativity. Already I told that factors, it is atomic size quite commonly and charges, nuclear charges. Okay, yeah, next we are going to talk about factors affecting the nuclear factors affecting the electronegativity. Factors affecting electronegativity. First factor, size of the atom, correct, or atomic size of the atom. Quite commonly in electronegativity we'll talk that En, electronegativity for taking, is inversely proportional to the size of the atom size. You see, if you take a small atom, is having atomic size, then electron affinity, electron negativity is more compared to large atom. Okay. Next, I talk on about nuclear charges. Nuclear charges will be, I told that the distance between nucleus and valency electrons, in nucleus having positive and the electron will be negative, we call that cation and anion. Okay. Charge on cation, charge on cation. Charge on cation is nothing but electronegativity is directly proportional to positive charge. Positive charge. How it is directly proportional? You see, the cations is more electronegativity than the parent atom, right? Cation is more electronegativity than parent atom or neutral atom. Okay, you can take example, Fe3 plus is greater than Fe2 plus, or Mn7 plus manganese is greater than Mn2 plus. Okay, next I am talking about the third point, charge on anion. M more, what will write here? Less. Okay, electronegativity is inversely proportional to negative charge. For example, O minus is greater than O2 minus, because you see here more electronegativity compared to here, because here electron repulsion are occurring. Yeah, more electronegativity. Okay, next fourth point, hybridization. If you talk in sp2, sp3, here the s having 50% orbital and 50% of p orbital. When come to here sp2 hybridization, here 35 or 33% p will be more. When come to sp3, here 25%. Next we are going to talk about applications. Next we are going to talk about applications of electronegativity. You see, the first application, that is a name compound. First application is nothing but naming of the compound or name compounds. You see, you take any element with a more electronegativity, the suffix will be id in last. Okay, we take example like HCl and SF6. Okay, see, HCl is nothing but hydrogen chloride, correct? No, hydrogen chloride. You see, id will be the suffix. To the electronegativity, having more electronegativity. When SF6 is sulfur hexafluoride. Sulfur hexafluoride. You see, id is a suffix. Then we will write that the element with more electronegativity, the suffix the suffix IDE. See, IDE is written at the end. It's the first for violating the naming of the compound. Okay. Second point, we can find the percentage of ionic characters in covalent bond. Okay, we can find the percentage of ionic character in covalent bond. We take HCl. It has the covalent bond sharing of the electrons between non-metal atoms. Okay, you see the sharing of electrons. The previous one I explained that the electrons are sharing. Correct? No, electrons are sharing. Then it is a covalent bond sharing of electron between non-metal atoms. You can take another example, NaCl, sodium chloride. It has ionic bond transferring of electron from metal atom to non-metal. You see, it is a metal plus it is non-metal. The electrons are transferring from metal to non-metal. Metal to non-metals. What you are having? Ionic bond transfer of electrons. Here covalent bond sharing of electrons between non-metal atom. Okay, they given the formula to find the ionic characters in covalent bond, that is 16 del X plus 35 del X whole square. What is del X? Is nothing but electronegativity. See, del X is nothing but electron negativity difference means it is delta is nothing but difference between two elements. For example, see, we take H and F. See, it's have the difference. Okay, like H having electronegativity 2.1, fluorine having the 4. If delta X, the electron negativity is 1.9. If you take delta X is equals to 1.9, then if you add it to this formula, 16 into 1.9 plus 3.5 into 1.9 whole square will get 43%. By using this formula, we can find the ionic characters in the covalent bond. Okay. Topic, that is electronegativity scale. It means the scales which gives the value of the atom having how much the electronegativity. The first one in that is Pauling scale. Pauling scale. Pauling scale is based on the bond order. Pauling scale is based on bond energy, nothing but the energy required to break a bond energy is nothing but the energy required to break a bond. Bond energy is nothing but, he given one formula. The formula is X means electronegativity of A, electronegativity of B element, it's 0.208 root of del. Del is nothing but where root del is equal to electron of A atom and B atom. Okay, bond energy is nothing but energy of bond energy of atom A and B minus root of energy of A atom into energy of B atom. Okay, given the formula. Okay, next we are going to talk about another scale, Mulliken scale. The Mulliken scale gives the average of ionization energy and electron affinity. You see, Mulliken scale gives to measure the Mulliken scale you use average of ionization energy and electron affinity. We will write that Mulliken symbol, Mulliken scale, to find electronegativity equals average of ionization energy plus electron affinity, okay, by 2. This is a formula used to find the electronegativity by using Mulliken scale. While if you tell that electronegativity using Pauling scale, the formula is, this is the formula. Okay, next the third scale we are going to study, that is of Fred-Rhonchow scale. He given the formula for electronegativity to find equals Z effect square by R. ZEF means effect of nuclear charge. You see, effective nuclear charge. Then E square is nothing but charge on electron. R is nothing but covalent radius. These are the three scales used to measure the electronegativity. Next we are going to study about period of valency. Okay, next we are going to study about periodicity of valency, or maybe also called as periodicity of oxidation state valency. Okay, it we have the will define that, our definition. The periodicity valency or periodicity of oxidation state valency is nothing but combining capacity of an electron. First definition is combining capacity of an element. Combining or you may be write another definition or second definitions. Electron lose or gain, electron lose or electron gain or electron shared. Okay, for example, you take methane. Methane is nothing but CH4. Example, methane 4. You see here it is methane. It having the 4 valencies. The 4 valencies, you see 1, 2, 3, 4. Here the carbon is giving, means a carbon have bond between the hydrogens, combining with carbon and hydrogens, combining capacity of an element, that is carbon and hydrogens. Okay, valency, there is a 2 types valencies. Okay, valencies are 2 types, that is one type is alright, valence is 2 type. One is electrovalency, one is covalency. Okay, what is electrovalency is nothing but number of electron lose or gain. You see what is electrovalency? Electro means electrons, electron valency means is losing or gaining. Okay, I'll write that number of electrons lose or gain. Okay, for example, you take NaCl. Here the metal means the electron, metal is giving to non-metal the electrons, means sodium giving the electrons to the chlorine, then sodium becomes cation, leaving the electrons, then chlorine is attracting the electrons, it becomes negative. Here 1 electrons are valency, means moving from sodium to chlorine, then we call it as 1 electrovalency. When come to covalence, number of bonds found by an atom. You see, number of bonds formed by an atom. For example, we'll take that bonds. Okay, we'll take that water, H2O. You see, if you talk here, the oxygen is bonded by an atom of hydrogen. Here bonding between the two hydrogens, while this is the first and this is second, then we will tell that it is 2 covalence. We will talk that it is 2 covalency. We understand the oxygen is bonded with the 2 hydrogen atoms. For that it will be 2 covalency. Okay. Next we are going to talk about for S block. S block, it having the 2, quite commonly we know that group 1, group 2. Group 1 it's a NS2 configuration. Sorry, group 2 NS2, group 1 NS1. It is alkyl metals. It is alkaline earth metals. You see, while taking the example for the alkyl metals, we take that the lithium, for example, its electronic configuration 1s2 2s1. The valency, you see, this is the valency were occurring. The s orbital must be filled with 2 electrons, but we are having the 1 valency occurring here, 1 valency. When come to alkaline earth metals, we take beryllium. If we write for 1s2 2s2, here 2 valency. The last orbital, how much electrons are present, that much of valency. Okay, for example, for if you take for p block elements, p block elements like halogens. The halogens having general electron configuration ns2 np5. It's the last orbital, it is a 7 valency. For example, we take the fluorine atomic number is 9, 1s2, 2s2, 2p5. It is second orbital, it's having 7 valency. Next we are going to discuss about d block elements. D block elements. You see, D block electrons are present in penultimate shell and outermost shell, correct? No, the electrons are present, sorry, we'll write electrons present in penultimate shell and outermost shell. Okay, you see, I will write the general electronic configuration for D block elements, that is n-1 d1 to 14 ns2. You see, here I told that the electrons are present in penultimate and outermost. You see, ns2, it is outermost shell. Then what about the n-d1 to 14 is penultimate shell. For example, we take the scandium, its general atomic number is 21, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. You see, the last valency means, actually if you write in the electronic configuration, first 4s2, 3d1, correct? No, 3d1. Here the 4 and 3 orbitals, the number of electrons are 2 plus 1, it is 3 valency. Okay, you see what I told, that 3d and 4s, if we can write that 3d1 and 4s2. See what I told, n-1, n is nothing but highest number is 4, correct? No, 4 minus 1, okay, d, okay, d 4 minus 1 3, correct? No, it will be 3d. Then ns2 is nothing but n is highest number, no, is 4s2, correct? No, I am writing here, the 3d already we told that 1, then n is 4s2, correct? No, this is the, here the 4s2 is the outermost shell and 3d is the penultimate shell. Next we are going to talk about F block. Means we are finding only the valencies of the S, P, D, F. We are taking some examples. Okay, in F block, electrons are present in penultimate shell, and outermost shell. We will write the general electronic configuration, that is n-2 f 1 to 14 n-1 d 0 to 1 ns2. You see, ns2, it is outermost shell. What about n-1 d to the power of 0 1, it is penultimate shell. Then n-2, it is anti-penultimate shell of the F block elements. Now we are going to discuss about variations of valency in periodical table. Okay. variations of valency in periodical table. Periodic table is nothing but we'll discuss about groups and periods, correct? No, it is groups, it is period. See, first we're going to talk about valency. Valency in period it goes on increases and then decreases. You see, in period valency goes on increases and decreases. You see, goes on increases first and then decreases. So we are not understanding, I will explain it. Example, we take the second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You see, while valencies are occurring here 1, 2, 3, 4, 3, see again it decreases 3, 2, 1, 0. You see, for lithium already explained, that is 1s2, 2s1. The 1 is valencies are occurring. Beryllium all told that is 2 valencies, that is 1s2, 2s2, correct? No, you are understanding? Similarly, I am telling that here if you boron, if you write 1s2, 2s2, 2p3, correct? No, like if goes on going, the what happening that the period in second period, not only period, in period what happened is to starting from it increases and then it will be decreases. Can you understanding in period? Now we are going to valency in periods. Valency in periods is over. Now we are going to talk about groups. Then what will tell? Increases and decreases, correct? No, in period. In groups it remains F block, it is below the periodical table, remains constant, it never not changes, fixed, constant, remains same or constant. Okay, example group 1. In group 1 we call that alkyl metals. NS1, its electronic configuration, it having 1 valency, it is fixed. No, if you take a group 16, that is group 16 group, it is cohalogens, its valency is 2 valency. Valency replaced by the term oxidation. You see, valency is very very important. Now valency is replaced by replacing by the term oxidation state or oxidation number. Oxidation state or oxidation number. Valency just a number, does not have charges. Valency, first of all, it is a number, does not have any charges. You see, we will told that 2 valencies and 3 valencies and 4 valencies. We are told that, you see, 1 valency, 2, 3, 4. I am not giving any charges to this. Well, come to oxidation state, it has charge possessed by an atom. Okay, possessed by an atom. One thing, first of all, what we take that in valency just a number. Valency just a number, but don't have charges. When come to oxidation state, it has in oxidation state it has a charge possessed by an atom. Example, we'll take one example. While taking example, you can understand that. Example, that is, first we'll take that OF2. We see, if you take for oxygen, atomic number is 8, 1s2, 2s2, 2p4. When come to fluorine, 9, 1s2, 2s2, 2p5. Here, when fluorine, it has the valency is 7. It has 7. Okay. You see, while writing the diagram, this is the diagram for OF2. You see what happening here. Oxygen giving the electrons towards the fluorine, means one electron is giving, correct? No, it giving means it must be a +1. First I am talking about here +1, here -1, correct? No, -1. Now again we are talking here, again this one electron giving to this fluorine, right side fluorine, it again +1, here -1. Then what we can write, 0 F, correct? No, -1 here +1 becomes +2. The two electrons giving from oxygen to fluorine for left and right side. You are understanding here? Okay. Next we are going to talk about another example, that is Na2O. The sodium electronic configuration. First we want to write the sodium electronic configuration: 1s2, 2s2, 2p6, 3s1. The valency is only one valency. Okay, one valency. Then when we want to write the oxygen. No, oxygen already written in above: 1s2, 2s2, 2p4. You see what happening here. The oxygen gaining the electron from the metal, that is, two electrons are gaining, because the P, it must be filled with 6, correct? No, the two electrons are gaining from the sodium, it becomes -2. Gaining the electrons, 2 electrons are gaining, then it becomes, what happens, 1s2, 2s2, 2p6, correct? No, 2 electrons are coming. What happened here? 1s2 in sodium, 1s2, 2s2, 2p5. Okay, then the 2 electrons are leaving, then it is +2. You see, order of electronegativity for this element and also this element, order of electronegativity is fluorine is greater than oxygen is greater than sodium. You see here what happened, the sodium is pulling the electrons from the oxygen, from sodium to oxygen. What I told you here, the oxygen giving the electrons to the fluorine, means, you see, the sodium giving electrons towards the oxygen giving electrons towards the fluorine. For that, we will write that electronegativity in order for FO sodium. It's complete the classification of periodic table and its properties.